This is a mixed gas stoichiometry problem. 20 grams of aluminum is added to excess nitric acid. What volume of hydrogen gas, H2, is produced at 800.0 millimeters of mercury and 20.0 degrees Celsius?
This next problem is a mixed gas stoichiometry problem. We know that with stoichiometry problems, we don't necessarily know the number of moles of our reactants going into them. We may start with a number of particles, a mass. In unit 4 or 5, we added concentration and volume as another way to figure out number of moles. And now we've added gas law calculations into the mixture. So there's about 25 different paths at least through a stoichiometry problem, but they all follow the same general pattern. Take whatever information you're given, get it to moles, work moles through your equation using your stoichiometric ratio in your second step, and in the third step, use the information that you have to get the quantity that you need. So, as usual, we're going to write our reaction. We're told that aluminum reacts with nitric acid, so you should be able to convert that to a molecular name of hydrogen nitrate and figure out that the formula is HNO3. This is a possible single replacement, and because aluminum is above hydrogen, it does occur. So we will have aluminum nitrate, and aluminums are 3 positives, so we know we need 3 of the nitrates to balance. Check your solubility rules, and this dissolves, and the hydrogen is displaced from the compound. We know that's a diatomic, so it will be H2 gas. So hydrogen is behaving like a metal in this single replacement reaction. You may need a couple of tries to get this one to balance, because, for example, if you put a 2 here to balance your hydrogen first, you would see that that would give you problems with your nitrates in the next step. If you were to put 3 in front of here to balance the nitrates, then you wouldn't be able to balance the hydrogen. So you need to up your ratio a little bit, and if we were to put a 2 in front of here, and a 6 here, a 2 here, now we should be able to balance this with 3 in front of H2, and everything should work out. Now that we have a balanced equation, we'll put in our given information. We're told as a starting point that we have 20.0 grams of the aluminum, and we're asked what the volume of the hydrogen gas would be at the end, and we're given some conditions that the pressure is equal to 800.0 millimeters of mercury, that the temperature is 20 degrees Celsius, so 20.0 degrees Celsius, and we know that we're going to need our temperature in Kelvin, so before I can forget that, I'm going to convert it to 293.15 K. I'm going to have to do a calculation with the ideal gas law here, so I know I need the correct unit for R. I need the one that mentions millimeters of mercury in its unit. So it's 62.364 millimeters of mercury over mole Kelvin. So I have 3 steps. The first step is to take this, convert to moles. The second step is to use my mole ratio to figure out the number of moles of hydrogen. And then the third step will be to use the ideal gas law and this given information to figure out the volume. So the number of moles of aluminum is the mass over molar mass, 20.0 grams over the molar mass. From the periodic table, 26.981,538 grams per mole. 0.741 moles. So I know my moles here is 0.741 moles, but I want to figure out the number of moles of the hydrogen from that. So the number of moles of H2 is the number of moles of Al times my mole ratio required over given. So 3/2. And I got 1.11 moles to 3 significant figures. So now that I know the number of moles of hydrogen, I have the pressure, the temperature, and the ideal gas constant, so I can solve for volume. The volume of hydrogen is equal to nRT over P. The number of moles is 1.11 moles. The correct value for R is 62.364 liters times millimeters of mercury over moles times Kelvin. The temperature is 293.15 K. And we're dividing by the pressure, which is 800.0 kPa. So when I ran this calculation, I got to 3 significant figures because of this measurement here, 25.4 liters. So as per usual, I invite you to check that out. Let me know if I got it right, or more importantly, let me know if I didn't get it right, and try some similar workbook problems for practice.